Hello everyone, I am Dr. Subhasish Saha, Assistant Professor in Physics, Department of HNS, MLR Institute of Technology, Hyderabad. So today I will discuss about crystal defect. So what is crystal defect? Before going to that, today's overview of this topic is crystal defect and classification of crystal defect. So question is, what is crystal defect? Crystal defect is, suppose we know a crystal consists of a regular and periodic array of points which contain atoms, ions or molecules. Now this is a crystal structure. This is a crystal structure. In this crystal structure, what we can do? Suppose there is some irregularity is there or some deviation is there which break the periodicity of the crystal structure. So that's called defect in a solid, means any deviation from periodicity in the solid or crystal is called defects. So suppose this is a regular and periodic array of atoms is there. Now if any atoms is missing or misplaced, so that is called defect, or that's violate or that deviate the periodicity or that break the periodicity of the crystal structure. That's why it is called defects. So it's break the symmetry of that crystal structure. So that sense it is called defect. That is called defect. So there are types of defects, classification of crystal types. There are three types of defects is there. One is point defect, second one is line defect and plane defect. So point defect has two parts. One is Frankel defect, Schottky defect. Line defect has also two division is there, edge dislocation, skew dislocation, and plane defect is tacking fall and grain boundary. So this is a classification of the crystal structures. Now question is, what is point defect? So we have idea about that. What is defects? Defect is basically due to dislocations or missing or misplace of the atoms, ions or molecules in the crystal structure which break the periodicity of the crystal structure, then it is called defects. So point defect, the classification we already mentioned: point defect, line defect and plane defect. So what is point defect? Point defect is, suppose if any one point, any atoms from a particular one point, it's missing or irregularly misplaced, okay, then it is called point defect. At a particular point is something missing or misplaced or dislocate, that's why the symmetry will break or periodicity will break, that it is called point defect. Now this is two part, one is Frankel defect, another is Schottky defect. So what is point defects? I mentioned these things. Point defects which are places where an atoms is missing or irregular misplaced in the lattice structure. So point defect should include lattice vacancies, self-interstitial atom, substitution of impurity atoms and interstitial impurity atoms. So main point is atoms is missing or irregularly placed or misplaced in the lattice structure. That's why it's deviate the periodicity or break the periodicity, then it is called point defect. So it is a particular point, a defect is happened, that's why it is a point defect. So there are parts is there. If it is misplaced or it is missing, then it is vacancy create. That is one of the reason. In self-interstitial atoms, it is misplaced in some different place. Substitution of impurity atoms or interstitial impurity atoms. So due to this reason, point defect comes. Another is linear defect or line defect. So what is line defect? Suppose it is a regular and periodic array of atoms, right? If the dislocations happens or periodicity breaks particular line of a crystal structure. Suppose this is here, this is my crystal structure. This is my crystal structure is there. Now it is a line, and a particular line, along a particular line, if the symmetry break, then it is called line defect. If it is either it's in these directions or in this direction, in a particular line, the defects happen. So that is called line defect. or it is also called dislocation. So line defect is which are group of atoms in irregular positions along a line. The linear, that is called line defect. The linear defect is also known as dislocation. Along a line, it is a line wise, it is dislocations happen. Now come to the discussion about point defects. I already discussed what is point defect. There are two types. One is Schottky defect, another is Frankel defect. Now question is, what is Schottky defect? So first understand from this diagram, then I read the definition. So Schottky defect is occur usually in ionic crystal system. So ionic crystal, suppose it is a NaCl or KCl, this type of ionic systems. So here is Na plus and Cl minus is there. Suppose it is NaCl structure. So these are Na plus, basically called as cation, and negative Cl minus, it is called anion. So these are symmetric structure of the crystal of NaCl without defect. It is a symmetric, like positive is Na, Cl is negative, again positive, negative. In this way, total symmetry is there. It is without defect. There is a without defect is there. Now what is Schottky defect? What is the defect in here? So in this case, Schottky defect means there is a missing of one of the cation as well as one of the anion. So it is a paired missings. Suppose this place, I have it is cation vacancy. Suppose in this place earlier, this is the position. In this place, now there is a missing of cation, and similarly this is the place, anion place, that is also missing. So there is a missing of equal numbers of cation and anions. Okay, so that creates a vacancy of equal numbers of cations and anions. So it is a paired vacancy. So that creates some defect in the crystal structure, which is called Schottky defect. Schottky defects in ionic crystal, that's, we can say that then Schottky defects in ionic crystals. Ionic crystal is suppose NaCl, KCl, arises when equal numbers of cations and anions are missing. Equal numbers of cations and anions. Equal numbers of cation and anions are missing from the normal sites, resulting in equal numbers of cation and anion vacancies is created. So if it is vacancy created, it is a paired number. Suppose one cation, one anion will be missing, or two cations, two anions. In this way, it is a paired vacancy created always. So even after defect, then the question is after defects, before defects, the how many numbers of like what is the numbers of cations and anions is there. Similarly, after defect, the numbers of cations and anion numbers will be equal. So this means suppose one cation missing is as well as one anion also missing. So after defect, even the numbers of cations and anions numbers will be equal even after defect. So that is called Schottky defect. Now it is just mathematical expression I have given here. At any temperature T, the numbers of paired vacancy, we already mentioned in Schottky defect, the vacancy will be created in a paired form. Either so it is number of paired vacancy equals to n into exp exponential e to the power minus ep by 2 kBt. So n is your number of paired vacancy. This is the how many numbers of paired vacancy is there in the Schottky defect. That is the mathematical form is there. So it is the number of paired vacancy. N is the number of atoms. Okay, it was there earlier without defect, and ep is the amount of energy required to create the paired vacancy. That is ep. Kv, we know Boltzmann constant. T is at a particular temperature. So this is the how many numbers of paired vacancy is there in crystal for Schottky defect. We can got the idea from this expression. Now come to the Frankel defect. What is Frankel defect? Frankel defect is slightly different from Schottky defect. It is also a point defect. So why it is called point defect? I already mentioned there is a missing or dislocation, missing or misplaced of the atoms. So that's why it is also called Frankel defect is also point defect. So what is Frankel defect? First come to the diagram. So in this is a like a without defect, this is a crystal structure. It is also applicable for ionic crystals. So without defect, this is a structure. It is a symmetric. Numbers of cations and anions are placed in a symmetric form. Okay, without defect, this is a diagram. Now, what is point defect is telling? Suppose any one of the cationic place or anionic place. From there, the that will be misplaced. Any one of the cationic or anionic place will be misplaced, and it's sitting on a interstitial positions. What is interstitial position? Suppose this is a symmetric. Interstitial positions is between four atoms. These are the interstitial positions. These are the interstitial position. So what is the place between two consecutive atoms or ion? These are the interstitial position. So suppose one of the atoms or ions misplaced and it's seated at particular one of the interstitial positions, then the defect is clear. That is called interstitial site. Okay, original positions is this is the original position. Suppose this is the original position of this anion. Now this anion is misplaced and come to one side, come to this position. This is position is called interstitial. It is in between atoms. It is not a, it's break the periodicity. That's why it is called defect, and it is a point defect because any one of the point is misplaced and it sit to the interstitial position. So that is called defect, and this defect is called point defect. So this is a Frankel defect, idea of the Frankel defect. So what is the statement then? Frankel defect is a point defect which is created when an atoms or cations, when an or anions leaves its original place in the lattice to create a vacancy while occupying the interstitial position within the solid crystal. So this is a definition of Frankel defect. In this case, without defect, numbers of cations and anions are same. Even after defects, the numbers of cation and anions will be equal because it is not totally removed out from the crystal structure. It is seated, but it is interstitial. It occupies the interstitial site or interstitial position. So even after defect, the numbers of cations and numbers of anions are same in case of crystal defect, like Frankel defect. So it is a mathematical expression at any temperature T. What is the n is the numbers of Frankel defects at a particular temperatures. Okay, what is the expression of these things? That is n equals to n into ni whole to the power half e to the power minus ei by 2 kBt. What is n? That is the number of defects created, Frankel defects. N is number of atoms present inside the crystal without defect that time. Now ni is number of interstitial site in the crystals. How many positions or interstitial site occupied by the atoms or ions, that is interstitial site. How many numbers are seated in the interstitial position, that denoted by Ni, and Ei is the energy. Ei is the energy required to produce this defect. So this is a mathematical expression for this Frankel defect. Now come to the next topic. This is a point defect I will discuss. Now coming to the next one is line defects. Today this is another topic. What is line defect? I already mentioned. The line defect means, suppose there is a box is there. Suppose there is a crystal. Okay, so defect is created along a line. In this line, along this line wise, the defect is created, or the defect will create along these lines. So then the periodicity will break particular line wise, then it is called line defect. That is called the defect in the crystals which extend through a line is called line defect. So it has two types, edge dislocation and skew dislocation. Now what is edge dislocation? So in case of edge dislocation, before going to that, I just draw a diagram. Suppose what is edge dislocation? In this case, suppose this is a crystal structure. These are the lattice point which is occupied by the atoms in the crystal structure. Okay, Okay. So this is the location of the atoms initially. Okay, this place. Now what will happen? What is edge dislocation? Suppose we this is a crystal structure without defect. Suppose now we divide these things in a plane. Suppose this is a line. We just take a half of these things line. Suppose this is my half of this line is. Okay. So there are 4 atoms is seated along this line. So half of this line is this one, which is marked by this dotted line. Now what is line defects? This is a half plane of this crystal, and suppose this is another line of this crystal along this line. Along this line, this is a half plane of this crystal structure also. This is a half of these things. Now suppose we insert a plane, we insert a half plane. We inserted a plane along these directions. Suppose we are inserting one plane along these directions, along this y-axis. So what will happen? Suppose in this case, initially this is a crystal structure overall. Now we insert one plane of this crystal along this half of this line. So when we apply inserting some plane through these directions, then what will happen? The nearest atoms, these atoms feel repulsion, it gets some pressure. So what will happen? Those will be little bit deviated from its original position. Suppose in this case, if it gets some pressure, if you insert some lattice plane along these directions, half of this crystal plane, then what will happen? These atoms maybe come to this position. In this position, these atoms slightly deviated in this position. These atoms is also slightly come to this position. These are also slightly deviated. Similarly, this one also, these atoms will be slightly due to inserts of another half plane. These atoms slightly come to this location. Okay, and this one is also come to little bit come to this location. Okay, so what will happen? In this case, since atoms are displaced along a line wise due to inserts of another plane, so now what is the structure will come? And this is also like, so what is happening here due to insertion of one plane? So the atoms are dislocate along a particular line. So that defect is created. So look into this. Earlier it was without defect, it is the diagram without defect. Now what is happening? Due to the insertion of plane, there is a dislocation of the atoms along a line wise. Earlier, so what will happen? The top of this plane will be distorted, is dislocated. Okay, this plane is dislocated, but lower plane or lower line is same. So the width of the lower line is same, but top one is slightly deviated. Thus dislocations occur along this line wise. Dislocations occurs along this line wise. So it is the extension of the top surface, but the bottom surface have the same width. So This is called edge dislocation. So dislocations happens or defect happen along the edge wise. So this edge is shifted to this side, and this edge is shifted to this side. So that is, so it's called edge dislocation. Now another dislocation is there. So we discussed already what is edge dislocation. In edge dislocation, extra half line is inserted in the crystal that create a defect along the line, and it is called edge dislocation. So this is a diagram I already discussed. Now come to the screw dislocation. In case of screw dislocation, what is happening? So what is screw dislocation? I'll explain that one. In this case, what is happen? Suppose what is happening in case of edge dislocation or screw dislocation. Suppose it is a crystal structure. This is a crystal structure. Okay, now we bend this structure. Okay, suppose this is a crystal structure, and this crystal structure we just bend this structure. Suppose we bend how these things. One portion is I am just pushing a force in clockwise direction, and another side I am pushing a force in anti-clockwise directions. So in that case, what will happen? The middle of this plane is there, middle of this line, that atoms are seated in this along this line wise, those are dislocated. It is called screw dislocation. Why it is called screw? Like you are forcing force in one directions, another force you are applying force in another directions. Okay, applying one force in clockwise, another case you apply the force in anti-clockwise. So it will happen like you are dislocate the crystal structure in this way. That's it's called, it is a screw. Like screw is like it is rotating, it is inserting when it's applying some force. Okay, another side you are applying some force in opposite directions, so it will make some dislocations or defects along the line of the middle of the crystals. That's why it is suppose it is a perfect crystal structure. Okay, now we apply some force in one directions. Okay, you are rotating like in one directions, another is you are applying a force in bottom one. So what will happen? So one of the plane, it's happened like along this line, middle of this line, the points are little bit deviated, so that's break the periodicity of this crystal structure. So it is called screw dislocation. After applying some force, what will happen? Some of the atoms are shifted in these directions, little bit deviated, and another is coming to these lower directions. So I hope it is idea is clear. Suppose when I bend this structure, suppose in this structure, when I bend this structure, so some of the points will be I am forcing in forward direction. Okay, so some of the points along a line, suppose in this is the line, some of the points are little bit shifted in this direction. Okay, and that line is coming to this portion, and some of the, it's now you are applying force in this direction, and in this case you are applying force in this direction. So some of the points are now in this direction. So what will happen? These lines, atoms are misplaced or dislocated. So this case, it is like a screw type of force you are applying in two directions. So it is misplaced, and that's why it is called dislocation. It is called and it is known as screw dislocation. When stress is applied in two opposite direction of a crystal, then there is a creation of screw dislocation. So it is called screw dislocation. I hope then it is idea is total overall clear about what is the defects. Today I mainly discuss about point defect and line defect. So in just make a summarize. So what is defect? Defect is basically due to the misplace or missing or irregularity of the points in the crystal structure which break the periodicity. That is basically known as defect. This defect has three parts: point defect, line defect, and plane defects. Today I mainly discuss about point defect and line defect. In point defect, when your particular one atoms is missing or misplaced on a particular point, then it creates a defect that is called point defect. It has two parts. One is Schottky defect, another is Frankel defect. In Schottky defect, usually paired vacancies form. Number of cation vacancy and number of anion vacancy are equal. That is called Schottky defect. In case of Frankel defects, it is in case of Frankel defects, a number of one of the cations or anions, it is applicable for ionic crystal. One of the cations or anions may be misplaced and those are sitting to the interstitial position. That is gives you defect, which is known as Frankel defect. Next is line defect. What is line defect? When the suppose in a crystal structure is there, now the defects happen in a particular line. Along a line wise, a group of atoms are dislocated along a line, then it is called line defect. It has also two parts, edge dislocation and skew. I already discussed what is edge dislocation. It's suppose along the edge wise the atoms are deviated. Okay, periodicities break along the edge, along the line wise, and one of the edge of this crystal structure is deviated, so it is called edge dislocation. Another is screw dislocation that I also mentioned. If you apply two opposite force on the crystal structure which actually twist the crystal, then what will happen? Along the middle of this plane, the atoms are there, those are misplaced due to the two opposite direction force you are applying. So that is also creates some defect. That defect is known as screw defect. So I hope today's overall discussion is quite meaningful and helpful for to get an idea about the defects. Okay, so thank you.